Hello folks, well we've got another radio from Trucking and Farming. I think there's one more which is the base station and that'll be it for this batch. Is it the 30th? It could be the 29th, it doesn't matter. It's an audio line, it's an audio line. I always think these are a little bit smarter than the Uniden ones. This one's immaculate. Yeah, well, I better open it up first though, because it's come with its original mic. Will run with a standard replacement mic. I'll take this lid off first, just in case we don't need to do the capacitors, but unless it's been serviced recently it'll need the capacitors doing. It's not prudent to power these up without checking those capacitors. So they've been done, but they haven't. Put the other glasses on. They've used Nikon ones, but they've not used the higher temperature ones. It's not the end of the world. I mean, I'll pass that. We'll have to do the two 470s because they can affect the amplifier, and we don't want to kill that. If those two 20s fail, you'll end up with no display. You can kill the phase lock loop chip, which is irreplaceable, and if the 470s fail, it can take the audio amplifier, which is expensive, apart from fake ones on AliExpress. I've said before, they're used in vintage arcade games of what same era, such as Tato did. So we'll do this first before powering it up. Which one is it? That one? Negative to the top. Negative to the bottom. I'll just go and get those. Okay, they're changed. So we've got a Uniden type lead on the bench. connected to the test equipment. Take the duster with us. We'll get this public address speaker, or the speaker on the wall, into public address socket. While I've got it like that, Audioline 341 1700 6549 2 times 470 microfarad. Right, I don't think I need to worry about how we power this up, because it's clearly been used relatively recently because of the way, or it's been tested relatively recently because of the way the capacitors have been changed. So we'll go for 13.8 volts, switch it on, we have a display, it says 19, we'll change that to 20, and let's see if we can, where did I put our standard replacement mic? I went to the trouble of getting it. Public address. Expect this is on the mic gain. Testing 1 2, testing 1 2 3 4 5 1 2 1 2. Good. Right, we'll bring the clipboard, and public address is working, meter lamp is working. Right, we'll go for transmit. I'll switch picture in picture on, if I can find the right button. We'll start on the 3 watt scale, so we should have full scale deflection. We've got beyond full scale deflection, and it's 3.4 watts. Go to channel 40. 3.3 watts. Channel 1. 3.3 watts. Back to channel 20. 783 milliamps. Low power. 300 milliwatts. Back to full power. Deviation on this test set. Now we're on CPT last. Well, it says 1.5, but I'll put the other test set on ready. I'll go for a cup of tea while that warms up in a moment. Let's see what the meter says for that. It says, well, it's supposed to be in the centre of the red. I'll just put low. Let's see the frequency. These aren't adjustable as long as it's within the parameters, and it's nearly spot on. 2779122. It's amazing how stable the crystals they used are. Alright, we'll do VCO when I've dug the service manual out, and let's go to the receiver. So we'll dial that into the signal generator 2779. We've had quite a spate of no transmitted audio, haven't we, on Uniden chassis? Basically, if these do anything under 1 microvolt, they're fine. Not as sensitive as Uniden, as Cybernets, but they get less bleed over, which doesn't matter an iota to me, but it does to people in towns. So we better plug in the test equipment speaker wherever it is. And that's bound to want an earth. So I'll put it to that coil for now. Make sure RF gain's at full. That sounds right. Hmm. 0.85, it sounds a bit detectorish though. Zero 0.78. 1.3. Squelched to full. Let's go over to the attenuator so you can see what I'm doing. And I've got it on 3. I want it to open at 30. Sorry, it's 100. It opens at 200 and... no. 2.3 millivolts. It's a bit harsh. Turn that down. Squelch to threshold. Coming in at... I'll change scales because it's 1.1 microvolt. Right, just make sure it does. Oh, I've tested all the switches. Just run through the transmitter, see if we can get another ½ watt out of it. Pop that off for now. We'll do the VCO in a moment. That's part of the receive. You either do it with test point 3, which we won't be doing because we already know the radio's working. In which case we do it with the cyanide meter on receive. But we will need to do the transmit VCO, which I'll do when we've got a service manual in front. Okay, let's go over to the main meter. You won't see what I'm doing. So we're on channel 20. Let's see if we can get a little bit more. So I want the centre of the peak. Just that one which was out. So that's 3.5 watts. So this one wants peaking, then we adjust the power on the final one. That's no difference at all. So it should come up on this one. Still a bit tight. There's 4 watts. Right, channel what? Channel 40, 4 watts. Channel 1, 4 watts. Beautifully even. You really want it to be within 0.1, but this has happened to work out exactly. 0.1 between the channel edges. Let's look at the current consumption. It's 882 milliamps. That is just absolutely incredibly low current for what it's doing. Let's do the meter. Want it in the centre of the red zone. Is it that one? No, that's low power. That's transmit meter. So that's centre of the red zone. Then on low power, just get that dust back central. On low power, it wants to do 400 milliwatts. Which is there. So that's most of that done. We'll do deviation when I come back from a tea break. Just see whether we can get somewhere with this receive. I'll just put my earth back on. I will put that earth back on. It sounds a bit iffy. Let's put it to that earth. I'm going to start with the detector. It just sounds a little bit either detectory or IFE. It's not had any DAW filters changed, has it? No. Good. What am I trying to show you? This oscilloscope. Just turn the volume up a fraction. So we want absolute centre of peak. Miles out. So that's going to affect the sensitivity, but it's going to sound right. Squelch off. I can't see that one yet. That is peak. Just go back to that. Turn that down to about 20. Well, that looks about right. Do the front end. Oh, tiniest little amount there. Let's drop the signal again. Go to the cyanide meter so you actually see what I'm doing. Trying to get the meter to move to the left. It's worse. That's peak. No change. Seems to be about where we are, but is that going to look worse on paper? Actually, no. .65 microvolts. .58 microvolts. Yeah, we're on that border. It says 1 on that scale. Let's try it on the other scale. It says 0.9 on that scale. So I'll tell you what, we'll give it the benefit of the doubt and put 0.95. Squelch. Squelch to full. back to the attenuator for you. I don't know what's in the way, but there's something definitely in that plastic bag. Right, squelch is to full. So it hasn't improved the squelch performance, so we'll need to intervene and adjust the squelch. It doesn't even ever want to open where I want it to be. We'll leave it at full. That's 300 microvolts. Get an exact figure. It's 220 microvolts, so that's fine. And let's turn the squelch down. Put the signal generator to standby. Put the squelch on threshold on the radio. Signal generator back on. .4. Let's give that another go, because that's not a good result. Just see if I can set it a bit more carefully. .96. S meter, we'll put the signal generator to 100 microvolts, and the signal generator now says what? Oh, it's a bit. It's quite close. In fact, we didn't test it before, so we'll do that. It's actually 300 microvolts. We just want to drop that a bit. S meter. Is there. Drop the volume. So it's 300 microvolts. That's now correct, and it's now 100 microvolts. They're right, and that's right. So when I come back, we'll do the deviation and the VCO. Just leave that on quietly so everything's nice and warmed up. Right, we're ready to do the deviation. So I'll put the main meter up on this one, but I'm actually plugged into the test set behind me. Let's see what it really is. Wow, it's just 2. Let's pop it up a little bit. Wow, low. Wow. Right, that's now spot on. So we'll plug back into the Marconi test set. I also printed off a page from the service manual. See where it is on here. Oh, wrong one. Wow, exactly the same. Our meters match today. So it was 2.0, it's now 2.2 to 2.5 absolute peak. Frequency, now everything's warmed up. 27,79126. I'll tell you what, whoever was making those crystals for them, 40 odd years old, and it's still bang on. Wow. VCO. Right, we'll get the multimeter wherever I've hidden it. Where have I put that? no idea where I put it. We'll use a different meter. So channel 40 is what we need to set the radio to. That's there. And we want test point 1. And test point 1, if I put my other glasses on, is the resistor just there with nothing on its insulator. It says test point 1 on the board. We'll go between there and a can for a voltage, and it's in transmit. I'll go on low pass, we're not heating the radio up. It's in transmit. Let's do that again. So they want it to be 3.5 volts, so it's 2.57, so it's low. Right, now I can't do all that with one hand, so we'll just have to get the negative. I'll get the negative on there along with that. Danger is that if you don't do this, you can end up with channels dropping out in some weather conditions. Right, so if I can key up and hold this on there, 2.5, we need to warm up that, and I've not put the soldering iron on. Might be enough. I don't want to dig down looking for it. Try that. So, I mean, this is only like an eighth of a turn, you know, to get it from where it was to here. I think we'll leave it at there. I just want to check, it doesn't tell you to, I just want to check on channel 1 that it's something sensible. And it is. So just so you see this, 3.5 volts plus or minus 0.1 volts at test point 1. And that's it. Now there is the other one we want to do. We'll go back to receive for, just get that disconnected, and perhaps by the time we do the next video I might find where the other meter is. So back to receive, channel 20, let's go to the synod meter, pop the squelch down. I don't expect this to be wrong at all, but we'll just check. In fact, take it to 6. No, it's spot on. So that's it, we are done. So all we had to do was change the 2 capacitors. I'll switch it off and we'll do the isopropyl alcohol where I've done the work. Don't know why I just couldn't get that off in one piece, but I couldn't. Hopefully this won't need to take any time to dry. That one and that one. put the first lid on it. We'll test the supplied mic. So I'll just unplug ours. We'll do the on-the-air test with ours. Hopefully we'll have Mr. Chippy today. I've looked at Christmas Eve, 24th of December, and I've got 4 church services to do. So it's a bit like that as a church organist in December. And then of course they've got you back on Christmas Day. So I've not done those tight. Let's just check the supplied mic. Let's see if I can find it. Or did I put it somewhere sensible? I put it somewhere sensible. I'm not going to take it out of its bag at this point, but we will on the air test. And that'll be just into our base station at the end. So I'm going to... Right, let's see what it's got to say for itself on this mic. Testing 1 2, testing 1 2. That's fine. Good. So we'll put the lid on this. And Bob's your uncle. And the saying is, and Fanny's your aunt. And I did have an Aunt Fanny. We had some relatives go to America in 1926 in the Great Depression, and Aunt Fanny, well, I think she was great Aunt Fanny, she ended up in a nursing home. I think it was in Florida. Anyway, it was called I'm trying to tell you a story. I can't even remember what it was called. But you didn't... Oh, yes, Sunset Rest Home. It didn't sound like you were coming out of there, did it? I think she was 84 when she passed away, which is certainly better than both my parents. My dad was 73, and my mum was 78. Let's just... I don't need to do this, but we'll just get which one's negative. Oh, just capacitors and everything, this meter. So that one to ground, to earth. Or that one. That's interesting. Why I'm not getting either come through. I'm still plugged in with extension speaker, that's why. No wonder nothing's happening. So definitely not that one. I'm not getting either come through to earth. It's either I can't work the meter, or there's no earth coming through to the speaker. Oh, I've not got the mic plugged in, have I? I'll get there eventually. Earth return comes via the mic. try that test again. Okay, one end, no, other end, yes, that's my negative. You couldn't make it up, could you? We started off with the extension speaker plugged in. We then didn't have the mic plugged in. This is really good working, and it's not because it's immaculate, you know, because it's a bit of a, you know, you can have 99 sets work like something, and then you get one that works a bit different, and this is the one that works a bit different, so that's good. So, as ever, I'll mention that the mics that originally came with these lacked treble response, a bit bassy. The radio's a little bit bassy, so with the two combination, the original mics don't sound that good in my opinion. So I always say it's absolutely great having the original mic, but always use a standard replacement mic because it's going to work better with that. There's some latitude with all these case screws, so while I'm holding it together, finish the screws. Okay, I'll get the aerial, I say aerial, I mean test equipment, switch the soldering iron off, switch the test equipment off, find the aerial on the roof, switch on, take it out to PA, channel 19, RF gain up, mic gain up. We're on low power. 1 nano, Roger. About tea time, so they'll be, mind you, they all sound off frequency, but then they will be, won't they? Right, so thanks for watching the immaculate Audioline PT341 from the trucking and farming customer, and we'll do an on the air test later on.